We convert the equation x equals 2 into polar coordinates and also solve for r. We directly substitute x equals r cosine of theta into the equation to get r cosine of theta equals 2. We divide both sides by cosine of theta to get r equals 2 over cosine of theta. And the reciprocal of cosine of theta is secant of theta. So r equals 2 secant of theta. Our answer, r equals 2 secant of theta. We check our answer by going to wolframalpha.com and I type in plot r equals 2 secant of theta. This graph is the same as x equals 2. Our answer is correct. We convert the equation negative y equals 3 into polar coordinates and solve for r. Y equals r sine of theta, so we can substitute it directly in to get negative r sine of theta equals 3. We divide both sides of the equation by negative sine of theta. R equals 3 over negative sine of theta. The reciprocal of sine of theta is cosecant of theta. It equals negative 3 cosecant of theta. Our answer is r equals negative 3 cosecant of theta. We use Wolfram alpha to check our answer again. We type in plot r equals negative 3 cosecant of theta. It is the line negative y equals 3 or y equals negative 3. Our answer is correct. We want to convert the equation x minus 1 squared plus y squared equals 1 into polar coordinates. We replace x by r cosine of theta and y by r sine of theta. Then the equation becomes r cosine of theta minus 1 squared plus r sine of theta squared equals 1. We use the trinomial square formula a minus b squared equals a squared minus 2ab plus b squared to expand the square. Then we have r squared cosine square of theta minus 2r cosine of theta plus 1 plus r square sine square of theta. I put it closer to this side because we can simplify. That equals 1. Then we remember the Pythagorean identity, sine square of theta plus cosine square of theta equals 1. So we simplify this equation into r squared minus 2r cosine of theta equals 0. We pull out the common factor r. The equation becomes r times r minus 2 cosine of theta equals 0. Then we have r equals 0 or r equals 2 cosine of theta. We look at the original equation. It's a circle centered at 1, 0 with radius 1. That means r cannot equal to 0. We reject that answer. Then our answer is r equals 2 cosine of theta. We go to Wolfram alpha to check again. We type in plot r equals 2 cosine of theta. The result is a circle centered at 1, 0 and the radius is 1. Our answer is correct. We will convert the equation y equals negative x into polar coordinates. This equation is written in slope-intercept form. The slope is negative 1 and the y-intercept is at the origin, 0, 0. We will sketch the graph. We find two more convenient points, one of which is negative 1, 1 and the other one is 1, negative 1. We join these 3 points together with a straight line. And we can see from the graph, since the slope is negative 1, the reference angle is pi over 4. We will solve this problem algebraically. We substitute y by r sine of theta and replace x by r cosine of theta. We get r sine of theta equals negative r cosine of theta. We notice that r cannot equal to 0 because we have a whole straight line instead of just the point at the origin. And cosine of theta cannot equal to 0 because there are no points when theta equals pi over 2 or 3 pi over 2 other than the origin. That means r cosine of theta cannot equal to 0. We divide both sides of the equation by r cosine of theta. We get r sine of theta over r cosine of theta equals negative r cosine of theta over r cosine of theta. That means tangent of theta equals negative 1. And theta is k pi minus pi over 4, where k is any integer. Our answer, we can simply write theta equals negative pi over 4 or theta equals 3 pi over 4. We convert the equation y equals 5x minus 12 into polar coordinates and solve for r. We replace y by r sine of theta and x by r cosine of theta. The equation becomes r sine of theta equals 5r cosine of theta minus 12. We add 12 to both sides and subtract r sine of theta from both sides. 12 equals 5r cosine of theta minus r sine of theta. We pull out the common factor r on the right side. We have 12 equals r times 5 cosine of theta minus sine of theta. We divide both sides by the parentheses. Our answer is r equals 12 over 5 cosine of theta minus sine of theta.